In this video, we are going to talk about functions. Okay, there are 4 ways to represent a function. You can do it verbally, and that's when you describe what your function does. You could do it algebraically, and that's when you write the formula, the math formula. You could do it visually. That's when we will graph it, and we will look at it. You could also do it numerically, and that's when we will create a table of values. You pick an x, any x you want, plug it in, and find out what is the y that goes along with it. Let's work on a few functions. Okay, we are given a function, f at x is equal to x squared minus 6. Okay, x is our input, and our f at x is just a fancy way to say y. So it's like y is equal to x squared minus 6. So my rule is to take the input, square it, and subtract off 6. So this says f at x. So if I said f at a heart, what would I do? Ooh, that's not a good heart. But remember, I majored in math, not in art. But I would take whatever is in here, I would square it, and I would subtract off 6. That is my rule. So let's get to work on the math. They want me to find f at -3, f at 3, f at 0, f at 1/2, f at 10. They have picked a lot of x's. They want me to plug it in and find out what is f at -3. That means, hey, just find your y when you plug in -3. What is f at 3? All that means is just plug in 3 and find out your y. So let's get to work. F at -3, wherever I see x, I am now going to plug in -3. So I have x squared. That would be -3 squared minus 6. -3 squared is 9, and 9 minus 6 is 3. So when I plugged in -3 for x, my f at -3, which is just my y, is 3. Let's do another one. F at 3. Wherever I see x, I will now plug in 3. So I will have 3 squared minus 6. 3 squared is 9 minus 6, which is also 3. F at 0, that will be 0 squared minus 6. F at 1/2, I will take 1/2, I will square it, and I will subtract 6. 1/2 squared, that is 1/2 times 1/2, which is 1/4 minus 6, and that will be a -5 3/4, or a -5.75. And the last value they want me to evaluate is f at 10. So I will have 10 squared minus 6. 10 squared, that is 10 times 10, which is 100. 100 minus 6 is 94. So I have talked about this function verbally. It says, hey, take your input, square it, and subtract off 6. I have also talked about this function numerically. I made a table of values. And of course, this is representing our function algebraically. This is the formula. And now let's look at a graph of f of x equals x squared minus 6. Now I could plot all these points on a graph, and you will see that you get a parabola. I'm going to show you how to do it on your graphing calculator. Okay, I'm going to plug in the function x squared minus 6. So here's my calculator. I'm going to go to the y equal button, my f of x, my y equal button. I'm going to type in my function number 1. Find your x button, square it, minus 6. And now I'm going to graph it. And there is our parabola. There is our graph of f of x equals x squared minus 6. And look here at your table of values. If I want to look at the table of values on my calculator, I can go to the second button and then graph which is your table. And remember, they told me to plug in 3, and I got 3. They told me to plug in -3. Here's -3, and I got 3. They also told me to plug in 10, didn't they? And here's 10, and I got 94. So we had our table of values right on our graphing calculator also. Our next problem, evaluate the function at the indicated values. My function is g at x equals 1 minus x over 1 plus x. So whatever is in this parentheses, my input, I have to plug it in wherever I see x. They want me to find g at 2, g at -2, g at 1/2, g at a minus 1, and g at -1. Let's get to work. G at 2, that will equal 1 minus 2 over 1 plus 2. In the numerator, 1 minus 2 is -1. In the denominator, 1 plus 2 is 3. I have my answer for g at 2. G at -2. Be careful here. I have 1 minus, and x is a -2. Do not make a careless error there. Then 1 plus x in the denominator, that would be 1 plus a -2. In the numerator, 1 plus 2 is 3. In the denominator, 1 minus 2 is a -1. 3 divided by -1 is just -3. I have my answer for g at -2. G at 1/2. Wherever I see x, I'm plugging in 1/2. So that would be 1 minus 1/2 divided by 1 plus 1/2. In the numerator, 1 minus 1/2 is just 1/2. In the denominator, 1 plus 1/2, that's 1 1/2, which is the same thing as 3/2. If I want to make this a little simpler to simplify, instead of 1/2 divided by 3/2, oh my goodness, we have a fraction within a fraction. We actually have 2 fractions within a fraction. I would rewrite this as 1/2 divided by 3/2. So you see, I just took the numerator, divided by 3/2, the denominator. So all I did is I rewrote this ugly, ugly fraction. This is 1/2 divided by 3/2. I just wrote it out horizontally, 1/2 divided by 3/2. And we know dividing by a fraction, you can multiply by the reciprocal. So I will have 1/2. Instead of divide, I'm going to change the sign. So that would be multiply. And the reciprocal of 3 over 2 is 2 over 3. The 2's will cancel out. Multiply straight across, I will get 1/3. So g at 1/2. So g at 1/2 is equal to 1/3. Let's keep working. I now want to find g at a. Is this confusing? All of a sudden, I plugged a variable in for another variable. Let's look at it. Wherever I see x, you simply plug in a. So instead of 1 minus x, I will have 1 minus a over 1 plus a. These are not like terms. I can't cancel because these are not exactly the same binomial. That's a positive 1 and a negative a in the numerator. In the denominator, I have a positive 1 and a positive a. Those are not the same. They're not opposite. You're done. Yes, it was that easy. So I have now found g at a is equal to 1 minus a over 1 plus a. I am now going to work on g at a minus 1. I will have 1 minus, instead of x, I will plug in a minus 1. Do not be lazy. Put your parentheses or you'll make a careless error. And then I have 1 plus x, which we will plug in a minus 1. In the numerator, you see that negative in front of the parentheses? That will be 1 minus a plus 1. I had to distribute that negative. That's when the signs change. In the denominator, it's just a plus in front of here. So nothing changes, but I will rewrite it without the parentheses. So in the numerator, I have 1 plus 1. That's going to be 2 minus a. In the denominator, I have a positive 1 and a negative 1. Those will cancel, leaving me only a. So this is our answer. G at a minus 1 is equal to 2 minus a over a. Do not cancel out those a's. The numerator is not a. It's not 2. It's 2 minus a. It's a binomial. Keep it together. It's divided by a. Okay, we have one more problem to go. The last problem, I'm looking for g at -1. So I will plug in -1 wherever I see x. So I have 1 minus x, which happens to be a -1, over 1 plus x. So it'll be 1 plus a -1. In the numerator, a minus and a negative become a positive. That will be 2. In the denominator, 1 plus a -1 is 0. I cannot have 0 in the denominator. That is undefined. So g at -1 is undefined because we ended up with 0 in the denominator. Okay, piecewise defined functions. In a nutshell, piecewise defined functions. That means it's a graph, of course, but part of it, like this part of this graph, looks like a parabola. That's y equals x squared plus 5x. F of x is equal to 7x. That looks like a line. So it's a function that is different pieces, and it occurs at different parts of the graph. In another video, we will talk about graphing piecewise defined functions. All I want you to do right now is to be able to evaluate piecewise defined functions at certain values. So once again, f of x, my y, is equal to x squared plus 5x if my x is less than or equal to 7. It is equal to 7x if my x is greater than 7. I want to find f at -5. Do I plug it in this piece or the second piece? F at -5, my x is -5. That is less than or equal to 7. So I will plug it into this piece. I will take my x, I will square it, and add 5 times my x. So I will have -5 squared plus 5 times my x, which happens to be a -5. -5 squared is 25. A positive 5 times a -5 is a -25. The answer is 0. Isn't that good? That's not hard. Now let's find f at 7. F at 7. My x is 7. So this said, if x is less than or equal to 7, plug it into the first piece. So that's what I will do. I will take my x, which happens to be 7 now. I will square it, plus 5 times my x, which is 7. 7 squared is 49. 5 times 7 is 35. 49 plus 35 is 84. For the last problem, I want to find f at 10. This x is greater than 7, so I will have to use that piece. Y, which is f of x, is equal to 7. Instead of x, I am plugging in 10. So f at 10 is equal to 70. Okay, now we're working on the difference quotient. The difference quotient occurs frequently in calculus. It represents the average rate of change. It's sort of a sophisticated slope formula. But remember, life does not occur in lines. Sometimes life is up, and sometimes life is down. So sometimes you can have a positive slope, sometimes you can have a negative slope. But in calculus and now, we will call that the average rate of change. So you need to learn the difference quotient to begin. So here is our difference quotient. F at a plus h minus f at a, all of that over h. I know, I bet you all wish I had a song for that too. I don't. Okay, so I want to find the difference quotient for this function. F at x equals 3x plus 2. Remember, this will represent the average rate of change. So this difference quotient, I have to find f at a plus h. I have to find f at a, and then divide all that by h. Our direction says, first of all, just find f at a. Well, f at a, wherever I see x, I'm going to plug in a. So that would be 3a plus 2. That was good. They also want me to find f at a plus h. Well, f at a plus h, wherever I see x, I will plug in a plus h. Make sure you keep that in parentheses. I can do a little bit of simplifying here. That will be 3a plus 3h plus 2. Now they want me to find the difference quotient, the entire formula, the f at a plus h minus the f at a, then divide it by h. Okay, so I need to take f at a plus h. That's what it told me to do, which is 3a plus 3h plus 2. Then they want me to subtract f at a, which is 3a plus 2. And then they want me to divide it by h. So here I go. F at a plus h, that's going to be 3a plus 3h plus 2 minus f at a. Well, f at a is not 3a, it's not 2, it's 3a plus 2. Make sure you keep that in parentheses. That is f at a plus h. I subtracted off, this is f at a, and I'm going to divide it by h. The rest is just a little bit of simplifying. 3a plus 3h plus 2. Distributive property with this negative, all the signs will change. I will have minus 3a minus 2, all of that divided by h. The positive 3a and the negative 3a will cancel. The positive 2 and the negative 2 will cancel. I will have 3h over h. My answer is simply 3. Now, let's notice something. So our answer is 3. So the average rate of change, the difference quotient for this function was 3. Do you notice something? This function is a line. You see, we just have x to the first. If you remember your formula, y is equal to mx plus b. The slope is whatever's with the x. The slope of this line is 3. But didn't I tell you average rate of change was sort of a sophisticated way of saying slope? Well, if it's a line, then yes, the slope is constant all the way up the line. In calculus, though, we can't assume that we'll always have lines. In calculus, we may have graphs. Sometimes the slope may be going up, sometimes down. Sometimes life could sort of be steady. So the average rate of change means what is the slope at that particular time? So yes, this problem, I could have just looked at this function and seen the slope, which is the average rate of change, because it's linear. But don't expect all of your problems to be linear, because that is not life. Okay, I hope you have enjoyed this lecture on functions.